In an experiment, the speed of light, c, is measured using the apparatus of FISA, which contains a light source, and a mirror. What between them is a wheel, with 720 notches. The distance between the light source and the mirror is 11.45 km, and the experimental value of c is 2.998 times 10 to power 8 meter per second. When the wheel is spinning, the speed of light is determined by passing through one notch of the wheel, and then returned through the next notch. Originally, the light is passing through from this notch, however, since the wheel is rotating clockwisely, after the light have been reflected, this notch will replace the original notch, and the light will pass through this notch. However, if the rotational speed of the wheel is not fast enough, when the light is reflected and try to passing through the other notch, since the next notch has not arrived yet, the light will be blocked by this part and cannot pass through it. Therefore, we have to calculate the minimum angular speed of the wheel so that the light can pass through the next notch. To begin with, we have to know what is the time needed for the light passing through the wheel and being reflected from the mirror, and back to the original point. We can use the equation, speed equals to distance, over time. Since we know the velocity is c, which is 2.998 times 10 power 8 meter per second. And the distance is 11.45 times 2, since it will go back to the light source. Finally, we can find out the time, and it is equal to this number. After that, we can use a formula, theta equals to W times t, where theta is the angular displacement, W is the angular velocity and t is the time, which is found in previous step. Then, what is the angular displacement we need? Since we have to find the minimum speed of the rotation of the wheel, and the angular displacement is the distance of one notch, therefore, the angle is 2 pi over 720, so that we can know the angle of one notch. Then, we can substitute all the number into the equation. Finally, the minimum speed can be obtained and it is 114 radiant per second. One important thing is that since it is in radiant, we have to change our calculator to radiant mode so that we can get the correct answer.